Hi. Hello, Rohit. Hello, Ganesh. So I'm Sai Gayatri Prasad. I am currently working as a data scientist at PepsiCo. Uh,
Okay.
like I have my bachelor's in mechanical engineering from Osmania University, and then I worked in Mahindra and Mahindra for a couple of years. And then I moved to the US for a master's in mechanical engineering from Stony Brook University. And
Okay.
after that, I worked as a data analyst at a company called Sysintelli. And and then I wanted to, I've always been, pretty excited or pretty interested in the field of mathematics. So,
Okay. Great.
and
Great.
Stony Brook is actually extremely good. It is one of the top-rated universities in the world for mathematics. So I pursued my master's in applied mathematics and statistics from Stony Brook University,
Okay.
but because they were giving me a scholarship, so I moved to Korea for that. South Korea for
Okay.
that. So, and then after that, I worked as a research assistant where I was working on deep learning problems. And
Okay.
I worked in various research positions, mainly machine learning and deep learning problems. So the past maybe so, and I moved back to India in 2021 uh, to stay closer to my family. Excuse me. Sorry. And I've worked in Mavenir systems. So there I was working for the telecommunication sector. We were working on
Okay.
something called reinforcement learning, wherein we tried to help the operators get the maximum productivity
Okay.
using the existing parameters. And currently, I'm working in PepsiCo for the past 7 months, actually 8 months. Uh,
Mhm.
I work with the marketing team to help them sell products better. Like so I'm into the
Okay.
e-commerce team. So
Okay.
yeah, so here we help the marketing team take better decisions for the uh, sale of products. So we try and give them insights into what product is giving what rate of return and stuff. So
Mhm. Mhm.
so I work on something called market mix modeling, wherein we use time series data to analyze the products, how the sales are, use
Okay.
different variables to help understand how each product is doing. Like for instance, if you're talking just about Pepsi, uh,
Mhm.
even in Pepsi, there's like multiple variants, right? Even in
Correct.
the variants, there are multiple, so there's the 1.5 liter, there's the 2 liters, there's 1 liter, there's a pet bottle. So
Mhm.
different configurations of they come in different sizes too. So
Mhm.
yeah, so which one is selling more? When is it selling? Which one to market? So all this because e-commerce is like the future, because we have reduced uh, you know going to the store and buying stuff. So I mean, although all of my work is US based, so that means we work with Uber Eats, Instacart, Walmart, and Amazon. So
Okay. Okay.
yeah, so that is a bit about me.
Great.
Yeah,
Great meeting, Prasad.
yeah. I hope I try to make the presentation extremely simple, because I thought
Yeah.
you know if I am able to speak it through my words, I'll be able to hold the audience.
Correct. Correct. Yeah, I think.
So I didn't want to fill the PPT with too much matter. It's not PPT that they are reading, right?
Correct.
So
Correct.
that is my opinion. So yeah. So in a nutshell, so this is how we would want. I mean, we are looking at in artificial intelligence. The whole space of artificial intelligence is actually making smarter machines and smarter decisions using a combination of different fields of data.
Mm.
So,
Mm.
so if you're talking about something called something like general artificial intelligence or AGI, uh, so that would mean it is cognitive enough to take smart decisions, wherein it starts with, say, we're talking about a robot, just something like
Mhm.
a robot. So it has to figure out what path it is doing. So that means it incorporates object detection, object segmentation, And these are parts of computer vision. So if we are giving it voice instructions, it has to be able to figure out, it incorporates NLP, wherein it goes in and retrieves or analyzes the data or analyzes the instructions per se, and goes ahead and finish the task. So
Correct.
that compasses artificial intelligence, and machine learning and deep learning are subparts of that. So machine learning is basically you're teaching this machine to learn uh, from the patterns of the data. So we are training any machine learning model, or rather we are training a machine to try and identify something as simple as maybe, yeah, okay. So let's say we take the example of housing prices. So I'm trying to jump in here because it will cover more use cases.
Correct.
Not just the robotics case. So say for instance, if a company wants to something like booking.com, or they real estate company, they want to analyze how what would be the housing prices. So that would mean we'll have input features would be things like number of bedrooms, the area, is there a garden, how is it how is the locality, how is the neighborhood. These are all variables that come in. Like if we
Correct.
are going so these are the variables that are coded it, and then we say we can try and fix the price of the house. So
Correct.
so based on these input variables, the output variable would be the price of the house. So if
Correct.
within this subset, if we are talking about deep learning is basically because we have a huge upsurge of electronic data. I mean, say if you're talking about something, let's take the example of visual data. So we all have pets. So we all have, like, usually cats and dogs. So if we're talking about something like a cat dog classifier, so we want the reason for the deep learning to exist is because we are sitting with the progress of the electronics, with the progress of so we have like tons of data that
Right.
helps us in analyzing the situation and analyzing the problem and solving the problem. So
Correct.
this the reason why this is deep machine learning is because it has the neural networks are deeper. That's it. That is the only reason if we can have machine learning with with the deep learning with one neural layer of neural network would be a machine learning problem. So the reason why we call it a deep learning problem is because we have multiple layers of neural networks. So that is the bigger overview. So okay. Is my screen visible?
Yes. Yes. Yeah.
Okay, so yeah, so this so this is the overview of artificial intelligence, machine learning, and deep learning. So within machine learning, we have, like, say, so I wanted to keep the presentation just to linear regression. So I'm trying to drive it towards that.
Okay.
Yeah. Yeah, please feel free to ask me questions, or say if I can elaborate on any part.
Okay. Sure. Sure.
Yeah. So okay. So within machine learning, there are like multiple options. So there's supervised machine learning and there's unsupervised machine learning, and even okay. So yeah. Okay. So if you're talking about what the machine learning problem, as we discussed, it's about building solutions from the data. So what we want to do is build an algorithm that would solve a particular problem from the data. So say what an example would be historical predictions. So the housing price classification is like we can try and modify the machine learning problem, the same housing data, to be maybe like a good neighborhood or a bad neighborhood, or a possibility of a sale or not possibility of a sale. So so
Okay.
clustering is also part of machine learning. reduction of dimensionality. So so these are all areas that we can cover. But yeah, so this is the overview of machine learning, and there are like multiple algorithms that we can go through, like linear logistic regression, support vector machines, which is SVM, and k nearest neighbors, random forests. So these would be coming under supervised machine learning. I'll tell you what supervised and unsupervised are, and where they differ in a fundamental way. And unsupervised machine learning would be k-means clustering. Oh, this is missing. K-means clustering and the principal component analysis, wherein so this is closely related to reducing dimensionality. Okay, so if you're talking about supervised and unsupervised, so basically supervised learning is where we already know the answer to a point. So for instance, if you're talking about something like if we can keep going back to the housing prices problem. So that is like so we know for each house, for say if it's a 3-bedroom house in a good location, in a with a garden, with a rooftop, with underground parking and all these, so that would cost some X amount, so X1 amount. So like that, we'll have a series of data. So that is basically we have the label for which for the input. So we have the Y for the X. So if you're talking about unprocessed data, we'll not know about that. So say, for instance, if we want to group a bunch of students. So in a classroom of students, what would be the number of students that would be, that would maybe do exceeding level in the subject of science. So that is a grouping that we can do. So we don't know for sure that there is an answer to that. So this is, we have some input variables that will lead to that. And we can, that model will build its accuracy over a period of time. So that is the thing. So this is like a prediction or classification problem. Say, so there's a future value of house. And this is like an email, if it's in a spam or not. So in this unsupervised, what we are doing is like we have tons of data. So and we're trying to just find some structure into it.
Correct.
So in supervised, again, because we have to prepare the data and label it correctly, it requires human intervention. And and here it does not exactly, not always will it require human intervention. I can give examples of this, but my goal is not to this. Rohit, before I proceed, like what is the amount of time that I have? I'm looking at.
I think 10-15 minutes will be fine.
Sure. Okay.
Yeah.
Because I have quite a bit of theory, and then I also have prepared one, small code
Fine.
snippet.
Okay.
So yeah. So and then in supervised learning, we'll have higher accuracy because we know the answer. We know the labels. So it is easier to solve those problems when compared to unsupervised. And it is more, the answers are more subjective, and we can clearly define our metrics here.
Okay.
Yeah. So this is the example.
Prasad, one question I have. So why dimension reduction is important?
So why is dimension? Okay, so this is so there is this thing called curse of dimensionality. So okay, so as we increase, say if I have 3 columns of data, it is easier for me to analyze, and there is a lesser chance of missing data when compared to if I'm having, say, 1,000 columns of data. And so my model will be able to identify the patterns better and figure out a problem in a more structured way.
Okay.
So that is the curse of dimensionality, because we'll not be able to so that is the curse of dimensionality. So there is more, the more the number of input variables, it
Hmm.
is the more likelihood of error.
Okay. Okay.
So that
And I think if if an additional column is not adding to the accuracy of the prediction,
mhm.
then I think there is no point keeping that extra column. So
Yeah.
we
So
can
so
reduce
yeah.
uh,
So we have
charging.
techniques like principal component analysis, which explain the variance in the data.
Correct.
So that would bring down this 15 or 1,000 to maybe like 15 easier, 15 manageable columns.
Correct.
Yeah.
So this house price prediction
Uh-huh.
or house price estimation is a classification problem or a regression problem?
Actually, we can make it both.
Okay.
So it is usually like the data sets that we get in the open source and net are regression problems. That is what we use to teach. I mean, we use them for, but we can make it classification problem. Say from this, say if given so we can add variables. So if we are talking about, okay, let me okay, okay, I'm able to edit this, right? Okay, so if my input variables are just say number of bedrooms and garden, uh, neighborhood, garden, and say area, uh, kitchen size. So if these are like, say, I'm just going to take these variables and say so for each this say my cost is say I don't know, 10 lakhs if this is right. Yeah, this is 10 lakhs. So if this is 10 lakhs. Okay, so these are my input variables. Okay, let me say I'll put this and say I'll say cost. Okay, so number of bedrooms is 3, garden is yes, neighborhood is good, area is like say 1700. I'm just gonna take just random numbers. I hope that's okay. So and if my cost is 10,000, so if I have uh you know mm, this is my data set.
Correct.
Okay, so this is my data set, and what I want to do is basically use linear regression. Oh, why is the size like this? Okay, regression to say given say bedrooms are like 4, good neighborhood no, garden yes, kitchen size is like 1,200, uh total area okay, total area is like 2,200, kitchen area is like just 150. So then what should ideally be my housing price? So then I can use linear regression for this.
Okay.
So the same thing, I can still use this data. I can still use this for logistic regression. This is a classification problem now. So and here, but my output variables will be sold, and maybe okay. So I'll add some other detail here. Number of bedrooms, just say person income. This is like buyer. Say it's like 15 lakhs per annum. Say this is like 30. This is 15 lakhs, right? Okay. So this is like only 5 lakh per annum, something like this. And so I can make this a logistic problem. Now it's like not sold. And this is sold. So based on this data, it is still a supervised learning problem. My input features are almost the same. There's a few new variables that but but thing is the output variable is a binary variable, discrete variable, sold or not sold. This is where I actually can come to this problem. So this is a regression versus classification.
Correct, correct.
Yeah, so this is where in the first example, where we are trying to, based on the previous or historical data, we're trying to see if we are able to fit the new data, predict the new data. So here we are trying to see based on the input variables, if there's a sale or a not sale.
Correct, correct.
So this is divided into classes. The classes here are not sale or not sale. Here the numerical value is the feature here. Something like this. Let's remove this. So that is my classification versus this problem. So, okay, so for linear regression, yeah, and classification, we use it for discrete variables, and regression, we use it for continuous variables. So that is I was coming to that. So if my dependent variable is continuous, then I will use a regression problem in general. And if my dependent variable is discrete, then I can use a classification problem.
Correct, correct.
Yeah. So in linear regression, it is basically trying to find a linear relationship between the independent variables and a dependent variable. So I'll tell you what the independent variables and dependent variables are. Okay, so I have it here. So here x can be x1, x2, x3, and so on. Any number of features are my independent features. Independent here means independent here means they don't relate to each other.
Correct.
And why is the dependent variable? Because we are getting the value of y based on these independent features. And these b0, b1, b2, or beta1, beta2, beta n are the coefficients.
Correct.
So if in a simple linear regression problem, we'll have only one coefficient, one intercept and one slope. This is like y equals to mx plus c. That's the line of, equation of a line. But if in multiple linear regression, there will be multiple independent variables. So beta y would be a function of different coefficients. Y would be a function of different independent variables, x1, x2, x3, and xn, so on. So yeah. So here our aim in linear regression is to fit a line for the given data in such a way that our error between the actual y values, which is if I want to go back to this example, these are the actual values. And this the model that will be trained on this data will predict something. This will be, say, y1. So this will be y2. This will be y3. Actually, y3 hat, because this is, and predicted would be y1. I don't know how to put that here. Excuse me. So this is the actual value, and the predicted would be this one. I'm really sorry. So yeah, so there's so this difference between this y1 actual and y1 hat, y2 and y2 hat, y3 and y3 hat, this difference between them should be low, and that would mean the best fit line, and would also mean least error. So that would automatically give the right relationship between the independent and the dependent variables.
Fine.
Okay. Yeah. So yeah, I wanted to introduce some, just a bit of math here, but I don't think that is necessary. But yeah, so if you're talking about input, these x1, x2, x3 and all are inputs. Y1, Y2, Y3, this would be the actual output. So we want to have a model that performs well. That would mean at any point yi hat should be approximately close to yi. The actual variable should be close to the the predicted variable should be close to the actual variable.
Correct.
And the idea of how we model this is through a loss function. And for regression, linear regression, we usually use the squared loss. I'll come to why this is the case too. So what we want to do is to minimize the j, which is the cost function. And the cost function is the loss, is the sum of all the losses or sum of the square of distances between the predicted and the actual values. And when we are talking about it in the mathematical notation, this is all the coefficients. This is all the x values, and this is all the actual value. So we can actually derive this from mathematical and also algebraic way, but I'm not going to try and do that. But yeah, so the idea here is to minimize the sum of costs over all the input output pairs. Okay. Yeah. Okay. These are some assumptions. I'll come to them. I'll try and show what. Just a second. Where's the other one? Okay. Linear regression. Just a second, please.
Yes.
Okay. So this is the student score. Okay. Let me try and. Okay. Okay. Let me. Okay. So if I'm trying to do this, but this is a train test split. Okay. So this will give this. Okay, I can use this. So here is my, this is the data that I have, like housing example. So here are my x values and y values. So here are my x and y values. And my idea is to predict, this is a very simple linear regression problem that we are trying to look at. Okay, so yeah, and I have, okay, so when I'm trying to model this in Python, I need to use some libraries. So that is pandas is a library for to manipulate the data. NumPy is for numerical Python, which is for calculations. Matplotlib is basically to for visualization, data visualization. So I have some data here, open source data. I just got this from one of the websites. I didn't create anything, but yeah. So if you're looking at this x and y, this is my input variable and input and independent variable, and this is my output and dependent variable. So these okay. Yeah. So this is in the form of a data frame now. When you're looking at a pair plot, and this is how x and y look like. So there is a linear relationship between them. So it is possible to model them using linear regression. Okay. Yeah. The reason why that is the case is one of the assumptions of linear regression. The first is both independent and dependent variables have to be linearly related. Okay. So we yeah, and then we split the train and test data. So there is a reason for this, because we don't test this data on a outside data or a field data. We test it from whatever data that we have curated. Correct. Right. So the reason why we do that is if our model is able to fit within the data that we have, then it is in general assumed that it will generalize to the outside data. But we'll still have to carry out tests for that. But this is the first step to that. So we split it into train, validation, and test sets. And yeah, so actually here I've used my gradient descent. But if I'm using my this is my function that actually creates all the parameters. This is my slope. This is my intercept. This is my cost function. Cost function, as you can see, is the mean of output and sorry, y hats, yi's and y hats squared.
Okay.
So this is my cost. So once I'm training this, at every step I can update. I'll tell you this is a slightly different variation. This does not use the normalization technique, but it uses the gradient descent technique.
Okay.
But yeah, but ultimately the model actually gives out parameters that we can look at. So if you're looking at this, this is our regression line, and this is the actual thing. So we can see that this is a bad way.
Correct.
Right. So, and it is evident from our loss function.
Correct.
Right. If I am say iteration, if I want to, so what I can do is I can increase the amount of iterations. Say something like, no, this is not the one. So if I increase the number of iterations, I can definitely get a better fitting line.
Yes. Yes.
So ideally, that would be something like something along this line. That would be something along this, something like this, a line.
Yeah. Yeah.
So yeah, so that is my linear regression, and actually, go back to my presentation. Okay, so yeah, so ideally, what I would want to be able to do is in any project. Okay, so if I have, I'm still drawing. Okay. So if I'm given any linear regression problem, first, my first step would be if I am looking at it from a coding point of view. Obviously, this is how we'll solve it, right? So we'll have to learn. We'll have to know that the relevant libraries, which is which are sklearn, scikit-learn is the most popular one. So, and then once we have the data, these are all sanity checks that we do to see the data, if the data types in Python are matching, if there's any change in data type that we need to do, and if and then there's also things like this is data visualization. So this is pair plots that we can use to see how each variable is correlated.
Correct.
Okay, so the first step would be to see if our data is following these assumptions. So there's like no multicollinearity, wherein that would mean, so you were talking about the dimensionality reduction, right? So if there's like 1,000 variables, and if the column is not adding any new information,
Correct.
so that is the multicollinearity part there. So, and we do something like homostat or we see if the residuals are spread out properly in, and so that there is no relationship between them. So there are tests wherein we see if the residuals are spread over there's no pattern in that, then it is fine. If there's some pattern, then we see that then we have to make some transformations like log transform for that particular variable and see or box-Cox transforms and see what how that residuals look like. And the and then this is predictors, which is the we'll have to see if they are distributed normally. So we use QQ plots or usually use QQ plots for this. Quintile plots. So yeah, and we see yeah, so that is one assumption that we'll have to satisfy. So each so this is the sixth one is the independent part. So if we are looking, I'll very sorry for this confusion because I'm jumping up and down.
No
Uh,
problem, no problem.
yeah.
So I
So
think
this,
uh,
yeah,
this will be good enough. So mm, I can ask something regarding the Python fundamentals part. If you have in your previous training, if you have done
yeah.
something on that.
Sure. I can. Yeah, we can do that.
Okay.
Hmm.
So Prasad, we are looking for uh, I can say 50, 60 hours course with some Python fundamentals where
Mm-hmm.
we will teach the learners about the important aspects of Python coding, which will be used for um, for data science and applying using various libraries like you have shown now.
Mm-hmm.
And then we spent 15 to 12 to 15 hours there, and then we moved to introduction to AIML, and the curriculum is already what all you have shown
Mm-hmm.
in uh, exploratory data analysis, then supervised learning, unsupervised learning, and then using linear regression, logarithmic regression,
Yeah.
cleaning our data. Then we can give examples of various use cases and problems in any using any editor. I think this one is VS Code only, na?
Hmm.
Yeah. So VS Code or Jupyter Notebook. Then we also do some small project which will use all the previously read concepts,
Mm-hmm.
and this can be winded up in 50 to 60 hours of uh, learning.
Okay.
So those kind of uh, uh, lectures along with these screen shares and some concept uh, on the slides also,
Mm-hmm.
which you can explain. Uh, so this is what we are expecting,
Okay.
and we want to start a batch, not a very big batch. It can be somewhere around 12 to 15 people, uh, 5 or 10 here and there,
Mm-hmm. Okay.
uh, over the weekend, most probably. So I think your weekends, uh, on weekdays, you will also be having offices.
Yeah.
In weekdays only, we want to run that.
So you want to run only on weekends or weekdays?
I think it will be for the working people, so they will be able to do over the weekends only.
Okay, that is fine. That is
Um,
better. Okay.
And once the batch will start, depending upon the audience, if they are comfortable on any weekday night time, then also it is fine.
Hmm.
Otherwise, mostly people are doing it over weekends only.
Yeah. Yeah. Sure.
Okay,
I'm fine with that. Yeah.
fine. So, Prasad, you have done this AIML batches earlier also.
So I used to teach in the university though.
Okay.
So no, but yeah, I'm fine with the. This was before the COVID and during COVID. So
Okay.
uh, yeah. So now most of the things are online. So I'm fine with that. Because PPTs and notebooks can be shared. We can make one group and share it.
Correct, correct.
Yeah.
Fine, Prasad. I think I enjoyed your demo.
Yeah.
So I think I will share the feedback with our team also, and I will talk to uh, Ganesh also,
Okay.
and he will let you know.
Okay. Sure. Thank you, Rohit.
So
Thanks for your time, Prasad.
Thank you.
any
Thank you,
other
guys.
Any other questions, Rohit, for me or for Prasad?
No, I think I'm done for now.
Okay. Okay, Raj.
Okay. Okay. Yeah.
Thank
Thank
you.
you.
Thanks
Thank
for
you.
your
Thank you. Yeah.